Next up, we have a talk to Microsoft researchers. Christine and Jonathan are going to be talking about bypassing TCC via Sploitlight plugins. So round of applause for Christine and Jonathan.
Oh, okay, we're good.
All right, so thank you, Patrick, for introducing us. My name is Christine Fossaceca. I'm a senior security researcher at Microsoft. I've been at Microsoft for a little over 3 years now. I've worked on Copilot. I've worked on Defender for Mobile. I recently started working on macOS. I've worked with Microsoft Threat Intelligence. So I kind of run the gamut a little bit. Unfortunately, our colleague Alexia couldn't be here today, but she is an amazing security researcher in her own right. She collaborated with us on this research. She's also written code for like the MD engine for macOS, so shout out to Alexia.
Yeah, and my name is Jonathan Baror. I go by JBO usually. I have tons of interests: Linux, macOS, cameras, routers, Windows sometimes, and I'm a research architect at Microsoft, and I like to do offensive security once in a while. Please.
All right, so before we get into what Sploitlight is, I'm going to give you a little overview of what we're going to talk about. We will give a background on TCC and entitlements. I know Wojciech gave a really awesome explanation of TCC yesterday, but just for the people that maybe didn't see that, we want to talk about it again. Also going to tell you what Sploitlight is, talk about the numerous past exploits that there have been. We'll talk about our exploit, and everybody loves a demo, so we're going to do a demo. Then we'll talk about Apple Intelligence and some of the sensitive data that can be leaked from Apple Intelligence, leveraging different types of exploits like ours, as well as detection opportunities to protect against those, and then takeaways. All right, so jumping into it, what is TCC? Again, if you're like, a seasoned macOS researcher, just tune out for a bit. But TCC is the transparency, consent, and control mechanism designed by Apple to govern access to like private data or sensitive data. So this is things like microphone, camera, like files, like desktop downloads, location information, just a lot of different things. This can be managed in the system preferences, privacy and security, privacy menu on the current iOS version, so it's just toggleable. And if you have seen this pop up, which you probably have, this is TCC. All right, and I'm realizing I forgot my notes, but okay, so TCC is controlled by the TCC daemon. So the TCC daemon is what reads and writes from the TCC DB. Now there's two TCC DBs. There is a per user TCC DB as well as a system-wide TCC DB. So in order to read or write to the per user one, you need to have full disk access. For the system-wide TCC DB, that requires full disk access, but it's actually protected by SIP. So even if you have root, unless SIP is disabled, you cannot write to that. So basically a TCC bypass is when you're accessing some type of TCC protected data, but you don't get this pop up in an oversimplified way. That's what that is. So I actually have an iOS exploitation background, so I didn't really know that much about macOS. And JBO has really been an awesome guide into all of the different protections that Apple has designed. So he explained TCC bypasses to me in this way, and I thought it was useful, and I wanted to share it with you all. So a complete TCC bypass would be anytime you can gain arbitrary access to most or all of the TCC service types. So this would be like overriding TCC DB. You're getting the ability to approve like all of these different TCC protected services to arbitrary apps. A partial TCC bypass would essentially be getting access to like one or maybe just like a few types, so maybe like just microphone access or like just access to the documents folder or just camera access or maybe like two of those. So now I'm going to talk a little bit about entitlements. So Apple also uses this as a privilege mechanism to control access to certain like really important or like sensitive things. So these are tightly coupled with digital signatures, meaning that the entitlement is embedded in the signature. And if a binary has an entitlement and that's changed, it's supposed to invalidate that signature. Doesn't always work that way. So there are public entitlements as well as private entitlements. Third-party developers are able to use those public entitlements to get access to different types of behaviors that they want to enable their apps to complete, such as like network access or accessing or reading and writing specific files. There's also private entitlements, and so private entitlements are really more for like Apple system processes or like special approved partners for certain things. So think of like the ESF entitlement, that's like a specific special entitlement. Some other private ones are like task ports, and of course TCC allow. So we're going to talk about some of those TCC special entitlements. So a TCC specific entitlement is important because that's when you think about these like different TCC bypasses, they're targeting binaries that have these TCC specific entitlements. A little preview or hint, JBO is going to tell you about MD worker shared. And so a TCC specific entitlement is going to be like COM Apple private TCC allow, COM Apple private TCC manager, and so a bypass is going to target binaries that have those entitlements. So to give an example, Safari is a pretty common target, and that's because it does have these entitlements. So you can see in this listing, there's access to the camera, there's access to microphone, access to screen capture, et cetera. And so because of that, there's no TCC checks on Safari with regards to those specific enabled entitlements. So now JBO is going to tell you about Spotlight.
Yeah, we'll put a spotlight on the Spotlight. Spotlight is, I bet all of you know about Spotlight because you search stuff. But basically, the idea is pretty simple. It's an indexing software that comes pre-shipped in every macOS. And the idea is that in order to find file names or contents, you don't have to grep your entire disk, which is good. And there are like two normal ways of interacting with Spotlight to search for stuff. One of them is command space and then looking for whatever. And the other one is mdfind. Here you can see in the screenshot me doing mdfind to search for all header files. And you can see, well, it's not an animation, but you have to believe me that it was very quick, obviously. Let's go next slide. And then in this example, this is me doing control space. And here you can see something interesting. I looked for the term POC. And besides the first three documents, where I don't know if you can spot it, but basically it has the term POC in the file name. But the last document there actually does not have the term POC in the file name. It actually comes from the content itself, which again kind of proves that Spotlight does more than index file names. It actually indexes contents of files. That's the entire point here. Now, Spotlight itself has been researched quite a lot, in fact, by some of the people in this room, and has been the target of a lot of different vulnerabilities, as well as well, I will talk later about how malware might use that. And it goes back like really, really early. I think Patrick talked about it like more than 10 years ago in Black Hat, about how people might abuse Spotlight to do evil stuff, basically. And after we released our information about Spotlight and how to abuse that, which is what we're going to do today, Patrick also, 10 or 11 years after, talked about it as well. So it's you know, an interesting area to explore always, I think. Now, Spotlight itself, we're going to do like a very high-level architecture. There are not only do things change between builds, I would say that there are a lot of moving parts, as far as I could see, that change rapidly. Some of those things is because of Apple Intelligence, actually, which has an interesting interplay with Spotlight. In a nutshell, we have a process called MDS. You need to think of it as some sort of like a manager. It actually does the heavyweight lifting of managing different workers, as well as managing the index itself. And then we have MD workers. We have two types of MD workers, or really two types of containing processes for MD workers. One of them is just called MD worker. The other one's MD worker shared. And they're pretty similar. One of them is supposed to index specific file types, and the other one's supposed to index specific file types, but it's a multi-tenant worker. Both of them are heavily sandboxed, and we'll talk about that in a sec. And then the index files themselves are stored in a special directory called .spotlight v100. That directory contains, obviously, a lot of private information. It's TCC protected. You can access that only if you have full disk access, and you have to have root to read those things. They're actually in each indexed volume. So if you look at /volume/ whatever volume you have, you'll find that this Spotlight v100 directory and tons of interesting files there. I did not analyze the format itself, first of all, because you need full disk access, and I was looking for something juicy. If you have full disk access, you basically bypass TCC. And then secondly, it's because it changes quite rapidly, actually, between builds, as far as I could see. Another interesting shout-out is Core Spotlight D, which is a daemon that kind of feeds Spotlight knowledge into Siri and Apple Intelligence. If you're looking for something very interesting to look at and how private data flows maybe to Siri, maybe to somewhere else, this is one interesting thing that I would look at if I had more time. And then there are several utilities that come pre-shipped on macOS to interact with Spotlight. We already talked about mdfind, but we will mention mdutil and mdimport, basically controlling Spotlight or instructing Spotlight to do certain things from your terminal if you want to automate things. Next. This is just a screenshot showing the Spotlight v100 directory that I mentioned. You can see here the different types of files, and obviously here I run, I basically have full disk access and I run as root. Next. Now, because Spotlight, if you think about it, the goal for those workers is to index certain file types, and it does not make sense that Apple needs to know how to parse every kind of file type. First of all, there is a lot of them, and secondly, there might be others that are maintained by other companies. For instance, we work at Microsoft. We fortunately or unfortunately maintain Office, and because of that, we need to know how to extract contents, right, from Word, for instance. And yes, someone else might do it for us, but Microsoft obviously is best positioned to do that. And Microsoft is not unique. Adobe could parse data out of PDFs and so on and so forth. And because of that, the architecture is not that you have one gigantic logic to load into MD worker, but there is a concept of plugins, right? It only makes sense. And those plugins are basically going to be loaded into those workers to do something useful, basically index data out of files. And those plugins are bundles, right? Like everything in macOS, it's a bundle, it's a directory structure. Looks very, very similar to the application directory structure, only that it has a .md importer extension. And in fact, you can find some of the built-in ones that Apple built themselves, commonly under System Library Spotlight. Obviously, you cannot override them. System is mounted as read-only and requires root, and also there is it's a sealed volume, which is a really big headache. But you can read and understand what they do, and you'll be able to see in this picture here that you have the list goes on and on. It's not just that, but here you have application and the importer that knows how to get it out of applications, archives that knows how to get data out of archives, and audio that knows how to parse certain audio and get data out. Now, because MD workers shared and friends have basically access to arbitrary files, the files that they want to get contents out, they are heavily, they basically are very powerful. Christine talked about it like 5 minutes ago, the entitlements that certain binaries might have. Well, MD worker shared has the COM Apple private TCC allow entitlement, which basically means that the set of values, these are string values under that key, are basically going to be the set of TCC service types, or that's the terminology that Apple uses, for which the binary is going to basically be allowed without a TCC prompt. So in this case, it has KTCC service system policy all files, which is a fancy word for saying full disk access, so it's extremely powerful. And there are other things that MD Worker Shared has access to, like your address book, your calendar and reminder. Those are different KTCC service types. We'll see that in a sec. And because of that, because MD Worker is so powerful, it basically is extremely sandboxed. Interestingly enough, the sandbox itself, when I reverse engineered it, you'll be able to see that it's loaded by MDS when it spawns those MD workers, as well as by MD worker itself. And some parts are done dynamically. Usually in sandboxing, you'll either find the sandboxing rules just in one file or even baked into like a binary. That's like, I don't know why, but MD worker seems to be special there. And again, heavily sandboxed. Basically, the goal of an MD worker is like read data and do nothing. So you can't like read arbitrary files at all unless you got that file from MDS. There is no network access, so you can't like leak data out. No forks, and the list goes on and on. It's the goal here. The message here is that it's heavily sandboxed. Now, yeah, this is. Yeah, that's great. Yeah, so this is just like if you want to see a part. Again, I mentioned that this is not a complete sandboxing rule, but you can gloss over and start to see all the different things that it can't or can do. There are certain things that it's supposed to be able to do, but those things are pointless for like exploitation for exploitation purposes. And then the other one is like an example. If you open, I think this one was MD Worker. You'll be able to see, generally, by the way, if you want to look at how Sandbox is basically loaded, then you might look for something like Sandbox extension issue file to self with like a certain argument that will eventually become like a sandboxing profile to load. And basically, this is MD Worker like putting itself in jail before it does anything useful. This is a screenshot of basically looking at the different entitlements of MD Worker Shared. Two things are interesting here. First of all, there is the flags. This is not, I think it was mentioned like a couple of times in this conference, but just to reiterate, this flags equals 0 is actually good or bad depending on your point of view. Normally, like in a hardened app, you'll have flags that basically say, oh, this has hardened runtime, and you can't load certain libraries into it. You can't run on-site code, and so on and so forth. Flags equals 0 is basically means like whatever goes. And then here are the set of KTCC services that MD Worker is basically whitelisted for. And you can see here the system policy all files, as well as I did promise the address book, calendar, and reminders.
Okay. So with Spotlight, you can actually code your own plugins if you want to parse Microsoft Word or something like that. And so something to note is it does not have to be signed. There's no need for root access. All you have to do is place your custom plugin under library Spotlight MD importer. So this is kind of where we got started with what we were doing here. So we were like, yeah, we're going to write our own plugin for Spotlight. Luckily, that's already been done before. Shout out to Chava. He actually has code currently online that shows not only how to write a custom plugin for Spotlight, but also actually how to use Spotlight for persistence. So definitely check that out. And it's really pretty simple. So remember, Spotlight is indexing your data, which basically means that you're writing a parser. So you're just telling Spotlight how to consume and process your data. So the three main things that you need to define here are an info.plist, which is a metadata file, and then there's actually a secondary metadata file that you have to define, schema.xml. And then the last part is just implementing a file with this function, get metadata for file. And that's it. So it was very, very simple. Again, newer to macOS, and I could do it. So JBO really reiterated how MD worker shared is sandbox. So it's even though Spotlight is accessing this TCC protected sensitive data, it's actually not sufficient. And we're only reading. But because of that, you're able to leak this very, very sensitive data that's supposed to be contained. So there's like weird ways that you can leak sensitive data, but we just chose to do it through this standard log. All right, I might zoom in a little bit here. So this is it. This is all of it. And it's actually kind of silly how simple it is. So remember I said that you're defining your parser because you're defining how you're going to index that data. So the first thing that you have to do is you need to point to the file, and then you need to know how big the file is. And that's it. And then the next thing that we had to do was we actually had to tell our MD importer to write to the log, and we decided to chunk it. Now, why did we do this? So when we first wrote like V1 of this, we were saying, hello world, hello exploit. It wrote to the log. However, when we tried to ramp it up with like a more juicy file, like a picture, we noticed that the log was truncating the file. So you can see here that we just chunked it in to 40 bytes. So you just send it in 40 byte chunks to the log, and then you're good. So this is it. But remember, I mentioned info.plist and schema.xml. So JBO is going to talk about those.
Yeah, by the way, this was semi-vibe coded.
Copilot wrote it.
Yeah, Chaba and then vibe coded. We talked, like Christina has showed, basically how the logic looks like. Again, super simple. You basically leak the data to a log, and then you'll be able to read it from outside. That's cool. But there are two things that are missing. First of all is triggering on arbitrary files, and the other one is declaring the right type of files. The triggering apparently is super easy. I did promise that I'll talk about utilities that come for your enjoyment to interact with Spotlight, and one of them is MD import. I bet it does some pretty complex, like XPC or whatever, but I didn't really reverse engineering to do anything. I basically read the manual, which is what all of you should do always. And basically, apparently in the manual, it even says, oh, you can import file hierarchies into metadata data store, which is a fancy word of saying index this stuff. And interestingly enough, there is a -i. There is a -i flag that you can give, and basically it says, hey, please take this file or directory, and if it's a directory, it's going to index everything recursively. So it's going to start discovering new file types, and based on the declaration that we have in our MD importer, it's going to basically call Christine's function or Chaba's function or ChatGPT's function. So that's pretty cool. We can basically trigger on arbitrary files. So one problem done. The other question is what to do about the declaration of file types. So this is going to be a bit short, not complete, but still. Basically, on Mac, file types are declared by a schema called UTI. If you come from a Windows world, you probably are, you're familiar mostly with file extensions, but you probably know that like file extensions don't mean anything. And basically, the way that files are declared is by an internal schema called UTI. UTI stands for Uniform Type Identifier, and you can basically, there are two tools that you can use, again, come pre-shipped with Mac. One of them is UT-type, the other one is MDLS, that basically can walk down this UTI, map a file into its file type, And UTI is kind of like a tree. So there is like inheritance for it. And here are a few examples. You can guess what those are based on the names here. So public.jpg is basically JPEGs. Public.text is text files. You have com Adobe PDF and com Microsoft Word doc, which kind of hints, again, that Apple does not have to know everything. Like third parties like Adobe or Microsoft can declare their own UTIs, which is great. It makes sense. And then there is dyn.blah. And dyn stands for dynamic types, and these are apparently created for file types that don't match a declared UTI. So you'll have like this thing instead of, I guess, an empty string, which is pretty useful, I guess. Now, if you can go to the next slide. Here you can see me using MDLS. I just took a PNG, and like here you can see it says like the type tree is public.png, and then you can see the actual inheritance. So public PNG inherits from public image from public data, and everything inherits from public content. So that's pretty useful. That's pretty cool. And again, if you wanted to do something with dynamic types, then you're kind of like in a situation, because dynamics types, as I mentioned, start with dyn and then something. That something is an opaque hash, and interestingly enough, it changes between machines. So if I have, let's say, a certain file type that is a dynamic type, and Christine on her machine has the same file, they will have a different UTI. So if you are an attacker and you land on a box, you can't like come with a pre-shipped like dyn dot whatever and hope for the best. It won't work. Like you'll have to resolve it. And but luckily enough, like we're super lazy when it comes to like creating like those offensive tools for educational purposes only. The plugin, as I think Christine has mentioned, does not even have to be signed. And because it's an app bundle or an MD importer bundle, you don't even have to recompile to leak arbitrary file contents. You basically like put it in the schema, and that's pretty much it. So putting it all together, it looks like this. This is a screenshot of the tool that we created. What it does here is basically leaking the file contents. If you can you actually go up a bit? So here, what the important part is that you can see me trying to do ls on a certain directory. I don't even have permissions to read that directory, but with this tool, you can actually read the thing and leak it out just the way that I mentioned. Let's move to the next slide. I think we have a video even. Yep. That's our demo, which is a recorded demo. Again, you can see no access at all. And then here you can see our tool. Basically, what it does is to plant like an MD importer, put a certain type in it, as I mentioned, calling MD importer, mdimport.i to like get all of the files out, and leaking data out of the log and reading those arbitrary files. So super duper simple. Now, what are the implications? Basically, we can read arbitrary files, which is pretty cool, because you're not supposed to be able to do that. And if you're an attacker, you can come with a slice and dice approach. Oh, by the way, I did not mention, but you cannot mention like the UTI type public.content. You can only mention like the leaves. It does not work if you like try to go for the root of UTI. Otherwise, we could just do everything, of course. But still, you can do a slice and dice. For instance, you want to get all, I think it was mentioned in yesterday's talk about North Korea using like a TCC prompt to get data out of downloads and documents, if I remember correctly, or desktop and documents. All of those are TCC protected, of course. Well, if North Korea saw this talk, I hope they don't, then they could basically use that instead. And you still have to know what you're looking for, but like all of the juicy data is usually like documents, pictures, whatever, right? So you can do a slice and dice. You can say, hey, give me all the PNGs, done. Give me all the JPEGs, done, and so on and so forth. And then we were thinking, like, what are super interesting files to read besides the obvious? The obvious are private documents. And then we decided to look at Apple Intelligence, and we decided, by the way, the entire reason why we started looking at dynamic types as well in the UTI, when I talked about UTI, is because SQLite databases are dynamic types. And because of that, we wanted to make sure that we can extract SQLite databases, which leads us, again, to look at Apple Intelligence, which Christine is going to talk about.
Yeah, I think that's a great foray into why we started looking into it, because we were thinking maybe Apple Intelligence will start parsing or caching or tagging or enriching some of these files for us in a way that's really easy to then index with Spotlight. So what is Apple Intelligence? You've probably heard of it, but it's essentially like a generative AI built-in technology on iOS, iPadOS, macOS, and it's supposed to be your AI personal assistant to make your life more convenient. So like if you lock your computer and walk away from it and you come back, maybe you see there's like a little summary of your notifications, which could be pretty helpful if you missed an important message from your manager or something, because your lunch went a little too long. It will also help you write emails and notes, and it will go through your photos in natural language, so just an easier way to index things for yourself. Also, if you miss a call, it will do audio transcription and summary of voicemails. So overall, super great, right? So convenient. My life is so much better. So this will have on-device processing, but this on-device processing also requires caching because there is so much data. So we decided to look at photo tagging data and those cached files, and this cache seems to be TCC protected. We also won't talk about PCC. Calista gave an awesome talk yesterday about that. But this is essentially the structure and all of the potentially super interesting files. So these things change across different operating systems. So we'll tell you which one is most important. But I wanted to talk a little bit more about photo tagging, and this is because in previous pre-Apple Intelligence, they did have facial recognition for specific people. It had pet recognition for specific pets. But Apple Intelligence has enriched that data, so it can get very specific. So even for a mixed breed dog, with accuracy, Apple Intelligence can identify a dog breed. You can see they knew what kind of dog I have, which is really, really interesting and convenient and awesome, right? But what other things do you take pictures of? Maybe when you're traveling, you take a picture of your passport, or maybe you have a picture of sensitive documents, or your credit card or something like that. And that stuff is also being enriched and indexed. So it's just a little something to keep in mind. So I said things change between operating system versions, and we were looking for the juiciest, most interesting data, and we decided that photos.sqlite seems to have a lot of the things that you might be interested in terms of sensitivity. So geolocation data, photo and video metadata like dog breeds, face and person recognition data, even deleted photo and video information, search history. And another thing to keep in mind, if you have multiple Apple devices logged into the same iCloud account, this means that your data is also being synced across all of those devices. So even if you have different things on different devices, it will all be synced. So here's an example of a photo that is, again, just something that you have to consider. If you have a picture of your cat, it's going to store the lat long of your house that we redacted. But just again, to get an idea of the structure, the different types of files are being automatically enriched and then saved and then stored for Apple Intelligence to leverage.
Besides all the different implications, again, think about how scary it is that you take a picture with your iPhone and then it gets synced into your Mac for someone to read, including your lat long. But besides that, even without Apple Intelligence, you can still get a lot of juicy data from just SQLite databases. This is not a forensics talk, but I had to mention a few things. So for instance, like your Safari history, you can actually extract that. You can see me here going to rickroll.com, which is not really a thing unless you want to get rickrolled. And then another thing that you can see here is the iMessage chats that contain like a lot of interesting information, including the contents, which again you should not be able to get normally. All of those things are TCC protected. You have other implications if you use like the built-in mail app, which some of you probably do. Then you can get like a lot of interesting contents. By the way, some of it is the summaries. Well, here the summary is actually just the text because I didn't send a long text, but the summary like might be created by Apple AI, I guess. So it's actually pretty useful. And you can read like arbitrary emails, you know, from like without normally getting the access to that with our exploit. You can get the current location. I think Wojciech mentioned like he did an entire awesome talk yesterday about location. Well, I used the same tricks apparently. I didn't know that we use the same tricks, but it's kind of obvious. If you open the weather app needs to know location. It saves it in in a SQLite database, which you can later read, and it saves it in a nice, even like serialized like JSON. And I'm sorry, by the way, for censoring. I just don't want everyone to come to my house, but it gives you a very, a very precise longitude, latitude, like an extremely precise one. So pretty cool. And in fact, if you think about it, Christine has mentioned that location is another TCC like service type that normally you shouldn't get. Well, here you get the location anyway without just by reading files. So I thought it was pretty cool. Besides that, if you're into forensics, by the way, this is probably the file that you want to look at. If there are folks here from Celebrite, they can tell you all about it, I guess. And this knowledge-seed.db is a huge database that is basically like an activity log of all the stuff that you do or don't do sometimes. It tells you like which apps you opened, when you got into a certain Wi-Fi, whether your battery was like plugged in or not, and so on and so forth. Here you can see me doing like I'm not a SQL person, but even I can do something like that. Basically extracting all the different like app activities. So you can spy on like someone's activity, I guess, or something. A lot of juicy stuff there. We don't want to leave you scared, not too much. So there are some detection opportunities here, which we already incorporated, by the way, to Defender. And I like there are a lot of folks here that do detection engineering, so I suggest that you take that into consideration. The low-hanging fruit, which I usually would not advise, but it's a low-hanging fruit. It's very easy to do. You just look for md-import-i, which, as I mentioned, is kind of critical to basically get Spotlight index stuff. Of course, it's just a low-hanging fruit. It's not durable at all because someone might re-implement the same logic that md-import does. All it does really is talk up using IPC. But it's still, most attackers, I guess, would use md-import, North Korea and such. And then the medium, can you go back a bit? Sorry. The medium hanging fruit, which is mostly useful, I guess, is unsigned or ad hoc signed md-importer bundles. Usually based on what I looked at when I looked at like our telemetry, they don't seem to be prevalent, so I think it's an interesting one. Those md-importer will normally be, because you can't write to /system, they'll be under your under a user's like library directory, under Spotlight importers, or under the /library directory if someone has root. By the way, to do all of the stuff that we've done here, you don't even need root access, of course. And then other things are anomalous editing of md-importer schema or info.plist. That was necessary to do the slice and dice approach that I mentioned. Like you have to change the UTI type to whatever you want. And lastly, the dynamic UTI interception by md-importer. If you parse like the schema of md-importers, then seeing something with dyn dot whatever is highly suspicious. Normally, md-importers would not do that. So I think that's something that you should definitely implement as logic. And as always, make sure that the box is patched. Apple has already patched this thing, which leads me to like the next slide, which is the patching. Apple's fix acknowledge that this is a nice opportunity to thank Apple for their collaboration. This appears under logging, and we started looking at like the fix, and fix kind of looks good. And then like whether the fix is good enough or not, we will discover in fall 2025. And then another pet peeve that I did have though, which is not fixed, and if you were in one of the North Korea talks about the human aspect of things, is that the only thing that stops for someone, unless they have a TCC bypass like this, the only thing that stops someone from stealing like the different Apple intelligence, at least the photos one that Christina and I and Alexia and I have been researching, is this TCC prompt. Now, it looks kind of okay. It doesn't say, hey, someone can like spy on you and get your location and do all the crazy stuff that like Apple Intelligence indexes. It's just like, hey, something wants access to your photo library, which I do find that like, I guess most users would just say yes. It's a pet peeve that I have with like the entire TCC protection mechanism, but it is something. I bet it can be improved.
All right, so just to wrap up, we want to reiterate, like with the rise of AI, privacy implications become increasingly dire. So, just remember that with all these agentic solutions, that also means that different processes are accessing potentially sensitive data, which may not actually be as protected as they should be. And I think as we've shown, TCC wasn't really enough to hold down the fort for this. So. Also just like design issues and like lack of like even needing to sign our exploits, like kind of bad. And so like Spotlight plugins are a risk to user privacy. We were not the first Spotlight exploit. We will not be the last Spotlight exploit. And variant analysis is pretty tough. 'Cause it just kind of keeps being hammered over and over again. So yeah. Thank you so much.
Do you want to do questions or one question? Any questions?
Any single question?
Yeah, single questions. Yes? Sorry, you have to speak louder a bit. Yes, I did test that, yes. In fact, we were able to get like pictures and there is a system default one for pictures as well, so yes. Yep, so yeah, you can have multiple MD importers working on the same UTI. There is no problem with that at all. Yep, which makes sense actually. Okay, so that was single question. If you have more questions, you can catch us later. Thank you again so much.
Thank you.